Okay, let's now do B. So the probability that the bag weighs between 8.97 and 9.17 ounces. So let's go back to our normal distribution, right? We know that we have a center of 9.12 and a standard deviation of 0.05. So 9.12 here goes in our center. And then if we want to go one standard deviation out to the left, 9.07, and one more standard deviation out to the left, 9.02. And then our last standard deviation out to the left, that's our 8.97, right? So there's 3 standard deviations left, 2 standard deviations left, 1 standard deviation left. Now let's build our standard deviations to the right. 9.17, 1 standard deviation to the right, 2 standard deviations to the right, 9.23. And again, I'm just adding this 0.05 every time. And then 3 standard deviations to the right would be 9.28. Right, just adding 0.05 every time. Okay, and now what do I want to know? I want to know what's the probability that the bag weighs between 8.97, so here's 8.97, and 9.17, so right here. Okay, so I want to know all of this, right? Okay, well, what do I know? I do know that all of my data, let's use black. No, black's bad. Right? I do know that, excuse me, not all of my data, but I do know that 99.7, right, would be contained within all 3 standard deviations. Okay? What else do I know? I know that here and here, that's 68%, right? Between -1 and 1. I know that between -2 and 2, right, I got 95% of my data there. Okay, but what about individually, right? Like how much is contained in each one of these little slices? Because if we could figure out how much is contained in each one of these little slices, all I would need to do is just add up the slices and I could get my answer. Well, let's figure that out. Well, I know this is 68% in here, right? So if I wanted, let's use yellow. So if I wanted to know how much is in each of these slices, right, I would just cut it in half. So 68 divided by 2, there is 34% in each one of these slices. Okay, let's go one further. Right, how much is in each of these slices? Well, I take 95, I subtract 68, and then because there's 2 of them, I would divide that by 2. So that's 28, excuse me, 27 divided by 2. So there's 13.5% in each one of these slices. Okay, so see, knowing how much is in each slice and then knowing how many of the slices they want, then I just have to add it up, right? And then let's go again. So if I want to know this slice and this slice, right? Well, 95% was contained within 2 standard deviations. 99.7 is contained within 3 standard deviations. So let's subtract out the 95, and then we got to divide it by 2 because there's 2 of them. So this is 2.7 divided by 2. That gives us to 1.85%. So in this guy, 8.5. In this guy, it's 8.5. Right? Because from here to here, sorry, 4.7. Excuse me, let me back up. 4.7, which would make this 2.35. So this is not this, 2.35, not this, 2.35. Excuse my error. All right, so which slice do I want? I want this slice and this slice. So 34 plus 34 plus 13.5 plus 2.35, right? So I add all those, 5, 8, 8, 10, 13, 6, 7, 8. So all my slices added up would be 83.85%. Okay. This diagram that I just drew here in yellow with these numbers, this would be a very good thing to write down because that's true of every normal distribution. That's the amount of data that's contained per slice. And then if you can figure out, like, okay, well, I want all these slices in the pink, then you can just add them up and then you don't have to make this chart every single time. Okay, so that is my suggestion for that. All right, let's do this practice. So let's kind of follow that same model, right? Let's make our normal distribution. Here we have a standard deviation of 2.5 and a mean of 69. So 2.5 to the right, 71.5, 2.5 to the right, 74. 2.5 to the right again to get us our third, right? This is 3, this is 2, this is 1 standard deviation, 76.5. To the left, -1 standard deviation, that's going to be 66.5. 2 standard deviations to the left, minus another 2.5, that'll be 64. Minus another standard deviation to the left, subtract 2.5 again, this would be 61.5. All right. Now, from the last example, we learned that there's 34% contained in that slice. There's 34% contained in that slice. We saw there's 13.5% contained in that slice, 13.5% contained in that slice. This slice, we saw there's 2.35, 2.35. Okay, so if I want probability that x is greater than 74, right? Also, there's 2.5% contained in this guy on. So from here on, there is 0.15 in that tail, 0.15 in that tail. Okay, so now we have everything we need. And this 0.15 is like from here to forever. This 0.15 is from here to forever as well. So if I wanted greater than 74, so here's 74, right? All I'm going to do is add up both of these slices. So that's 2.35 plus 0.15. Okay, so 2.5%, right? So the probability that a random data point is greater than 74, 2.5% or 0.025. B, the probability that the man has height between 64 and 71, okay, between 64 and 71, excuse me, 71.5. So that's these 3 slices here. We've already computed how much data is in each one of those slices, so we just add it up. 13.5 plus 34 plus 34, 0.5, 8, 11, 6, 8. 81.5. You will be recognizing we get a lot of these numbers that are similar. So the probability that we fall in this range, right, just add up the percentages. That's what's great about empirical rule. It doesn't matter what your mean is. It doesn't matter what your standard deviation is. The same amount of data is going to fall in these slices regardless of the mean, regardless of the standard deviation. This is always the same for every single normal distribution. That's the beautiful part here. So please take your quizzes, which is in your Canvas. After that, please do your exit ticket, which is also in your Canvas. Good luck, you guys. And if you need anything from me, please just email me.